Today we're going to learn about prime factorization. Yesterday you took a vocabulary word called factors. Remember, factors are the numbers that we can multiply together to get another number. Okay, for example, 4 and 2 are factors of 8 because 4 times 2 equals 8. And then we also learned that a number is divisible by another number if you can divide it and there's no remainder. So 8 is divisible by 4 and 2. Our factors and divisibility, those are closely tied together. So today you're going to need to remember your divisibility rules as we learn about prime factorization. Okay? Now, in this first example, Anna wants to build a rectangular garden with an area of 24 square feet. What are the possible whole number lengths and widths of the garden? So they tell us first to recall that area equals length times width. And her garden is 24 feet squared, so it's going to be 24 needs to equal our length times width. So if we list all the factors of 24 in their pairs, then these are the possible lengths and widths for her garden. Okay, so we have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Okay, and they also show this using factor pairs, which means that our possible lengths and widths, she could have a length of 24 and a width of 1, a length of 12 and a width of 2, a length of 8 and a width of 3, a length of 6 and a width of 4. Okay, so these are just regular factors of 24. All right, now prime factorization, okay, is when we are going to find the prime factors of a number. Okay, so these are the prime numbers that if you multiply them all together, you end up with your original number. Now, keep in mind that a prime number, this is one of your vocabulary words, a prime number is a number that can be only divided by 1 in itself. So the number 2 is prime because it can only be divided by 2 to get 1, or divided by 1 to get 2, and that's it. Composite numbers are numbers that can be divided by 1 itself and at least one other number. So like the number 12, I can divide 12 by 1, I can divide it by 12, I can divide it by 2 and 3 and 4 and 6. It has lots of different factors, so it's a composite number. All right, now we're going to start using a factorization tree in order to find our prime factorization. Okay, they're starting us off with a pretty big number, 240. I'm actually going to start with a small number. Let's see where they got this information for the number 12. Okay, so our factor tree starts out with 2 branches. And you're going to put on the end of these branches 2 factors of 12. So I know that 12 can be divided by 2, right? That's one of my divisibility rules. It's an even number. So I could say 2 and 6 multiply to get 12. All right? Now, I'm looking for prime numbers. 2 is a prime number, so I'm going to circle it. It's going to stop there. But 6 is composite, so it gets another set of branches. Okay? Because I can multiply 2 things to get 6. What can 6 be divided by? It can be divided by 2. So let's do 2 and 3. 2 times 3 gives me 6. Now, 2 is prime and 3 is prime. All right, so since I have no other numbers to put branches on, no other factors to find, I'm left with the prime factorization of 12. So we list these multiplied together. So 2 times 2 times 3. And remember your lesson from the beginning of this week. If you have the same number being multiplied, we can use an exponent to simplify that. So 2 to the second power times 3. That is the prime factorization of 12. All right, now that we've tried an easy problem, let's go back to their very difficult problem, 240. All right, so they helped us out. They said 240 can be divided by 48. Okay, so let's see. How did they get that? I'm thinking probably 5. Let me check. 48 times 5. That's 40. Yep, 24. There we go. All right, so 48 times 5 gives me 240. Now 5 is a prime number, so I'm going to circle it, but 48 is not. So something times something can give me 48. I know 48 is even, so how about let's do 2. 2 times, and that's 24, gives me 48. 2 is prime, so I circle it. Now 24, it has its own factors. It's composite, so I'm going to multiply. Let's do 2 again. Oops, wrong color. 2 times 12 gives me 24. Again, 2 is prime, 12 is not. 12 gets branches. 2 and 6. 2 times 6 gives me 12. Circle that 2 and give 6 branches. And then the last one's 2 times 3. 2 and 3 are both prime, so we stop there. All right, so we're going to list the prime factorization of 240. So I'm going to start with my small numbers. 2, 2, 2, 2. 2 times 2 times 2 times 2. And then I have 1, 3 and 1, 5. Okay, and then we can write this using exponents. How many 2's do we have? We have 4 of them, so 2 to the 4th power times 3 times 5. That is a very long prime factorization. All right. So I know this is a little tricky, but we use the factor trees to help us find the prime factors. And then we write those using exponents in order to show the prime factorization. Something that you might want to add to your spiral, a list of prime numbers. Okay, these numbers are the ones that you would circle. 2, 3, 5, 7, 11, 13, 17, and 19. Okay, prime numbers go on forever and ever and ever, but I'm just going to stop there. The next one would be 23, but I'm just going to stop at 19. And let's do one more example. Let's do the prime factorization for the number 45. All right, so you ask yourself, what can 45 be divided by? Well, I see it ends in a 5, and I know numbers that end in 5 can be divided by 5. Okay, how many 5's go into 45? 9. So, 5 and 9. If I look at my list of prime numbers, 5 is on that list, so I'm going to circle it. 9 is not on that list, so it gets branches. 9 is composite. What times what gives me 9? I know 3 times 3 gives me 9. Okay, so 3 is on my list, so I'm going to circle both those 3's. I have no other branches to be made, no other composite numbers, so that means 45. The prime factorization is 3 times 3 times 5. And we can use exponents to simplify this. I have 2 3's, so it's 3 to the 2nd power times 5. All right, put these examples in your spiral and get your vocabulary written.